Hello and welcome to Lesson 8.2. Today we're going to look at what we call scientific notation. Ultimately, what scientific notation is this is a format that's going to make it easier for us to write numbers that are either really, really small or really, really large. And this is something that you're going to see in math classes, and you're also going to see them in some of your science classes. And even if you read the newspaper, sometimes they will show numbers that are, like I said, really big or really small in scientific notation as well. Okay, so by definition, scientific notation is a number that's written as the product of two factors in the form of a times 10 to the power of n, where n is an integer, and the number a is going to be in between 1 and 10. Now, that number a can be 1 because notice it says 1 is less than or equal to a, but the number will never be 10, okay? So it can be 9.9999, okay, but it cannot actually be 10. So some examples, you can see we have 3.4 times 10 to the 6th power, 5.43 times 10 to the 13th, or 2.1 times 10 to the negative 10th. So we can have both positive and negative exponents, but the ultimate thing you have to remember is this number here in the front has to be a number in between 1 and 10. The base of all the powers are always going to be a 10, and then your exponent has to be an integer. Now, I'm going to show you real quick on your calculator how you would type some of these in. And then when we are in class, I will also go over this with you again as well. So on your calculator, if you want to type in a number, something like this here at the top, 3.5 times 10 to the third, and this is just the app called The Calculator. And before you do, you can see this screen here, you do need to make sure that at the bottom you are in the scientific mode. And what you're going to do is you are going to type in this, and it has to be in this order. You're going to go 3.5, and then the key thing here is you're going to hit this button that says EE, okay? So EE, and I'll write this up here, really takes place of times 10, and then it's going to give you like the power, okay? So then if I type in 3.5 and then that EE button, that's really giving me this part right here. And then I have to go in and go ahead and type in the 3 again, and that will give me the exponent. So your calculator will also show you down here at the bottom what you just typed in. So it says 3.5 EE3. That really means this notation right here. And if you hit the equal sign, it does show you that that's 3,500. Now, when we get into doing calculations, okay, I also wanted to show you what you may see, and you'll also see this notation sometimes on our classroom set of calculators. Notice down here at the bottom, okay, I typed in a few numbers. I have 9.9, EE means times 10, and I did times 10 to the 25th, and then what I did is I multiplied that by 1.03, and then the EE means times 10, and then I have an exponent of 7. Okay, so once I hit enter, I get this number right here on my screen. Now, with really big or really small numbers, a lot of times you have to pay attention because notice I have this E right there. What that means, that E being right there tells me that my calculator screen did not have enough capacity to hold all the numbers that it needed to show, so it's going to put my answer in scientific notation. So my answer to this is going to be 1.0197, and that E means that it's times 10, and my exponent is 33. Now, if you wanted to, you could go ahead and switch that to maybe 1.02 times 10 to the 33rd, and this is probably what I would write on my paper. Again, we'll go over this in class once everybody is here, and I'll make sure that you guys are good with at least your iPad calculators. So for example 1, it wants us to tell whether or not the number is written in scientific notation. So if we look at part A, we have 56.29 times 10 to the 12th. Okay, and so when I look at this, right away, I notice that I have 56.29. Okay, this tells me here that this is not written in scientific notation because 56.29 is not a number that is in between 1 and 10. So what I would have to do to put this in scientific notation is I actually have to move that decimal place over one more place, and I would have to make this 5.629 times 10. Because I moved it one decimal place, I'm going to make that to the 13th power. For part B, I have 0.84 times 10 to the negative third. Okay, again, I have another red flag because again, 0.84 is not a number in between 1 and 10. So again, this would be no, it's not written in correct scientific notation. Part C, I have 6.11. Well, that part's going to work because that is a number in between 1 and 10. Next, I'm going to look at, I have times 10. Okay, so I have a power with a base of 10, and I have an exponent of 5. So this one right here, and 5 is an integer. So this does meet the requirements for scientific notation. When I come over into the second column here, I have 52 times 10 to the 4th. Again, my 52 is not a number in between 1 and 10. So this would be no. For the second one down in that second column, I have 3.42 times 10 to the negative 7. Well, 3.42 is a number in between 1 and 10. I'm multiplying by a power of base 10 raised to a negative exponent. This is fine. So I'm going to say yes, this is correct. And then for my last one, I have 0.04 times 10 to the negative 5th. Again, 0.04 is not in between 1 and 10, so this is a no. Now, when we are writing numbers in scientific notation, there's something that we have to pay attention to, okay? Ultimately, we're looking to see if we have a number that is going to be greater than 1 or a number that is less than 1. Okay, so when I look at this example right here, it says, notice that it says positive exponents are used to show numbers that are greater than 1. So I have 2300, okay, and I want to write this in scientific notation. So ultimately what I have to do is, and I don't know if you know this or not, but if you don't, if you are not given a decimal, we always assume the decimal to be at the very end of the number. So this is where my decimal would be. So I need to figure out where I have to move that decimal so I end up with a number that is in between 1 and 10. So notice if I move it up here between 2 and 3, this is 2.3. So 2.3 is a number in between 1 and 10. And I'm going to multiply it by a power with a base of 10. And then my exponent, or the number that goes up here, is going to be the number of places I move my decimal. So I moved it 1, 2, 3 places. Oops. So I moved it 3 places, so I'm going to have an exponent of 3. Now because 2300 is a number that is greater than 1, my exponent is a positive 3. So I have 2.3 times 10 to the positive third. Now we also have the case where we have negative exponents. And negative exponents are used to write numbers that are in between 0 and 1. So again, if I look at this example here, where I have 0.0035, okay, in order to write this in scientific notation, again, we have to write it where I have to move my decimal place so that it's a number in between 1 and 10. So that tells me that my decimal place has to go in between the 3 and the 5. So I end up with 3.5 times 10, and then I move my decimal place 1, 2, 3 places. But because my original number was 0.0035, this is a number in between 0 and 1, so that tells me that my exponent then has to be negative. So this right here then would be my final answer. So let's go ahead and take a look at example 2, because this is going to show us or give us more practice with doing this. Okay, so for this first one here, I have 267,000. Again, if I don't have a decimal place, we're going to put it here at the end. And I see that I have to move my decimal all the way over here in between that 2 and that 6. So that gives me 2.67 times 10. And we move that decimal place 1, 2, 3, 4, 5 places. And because 267,000 is a number that is greater than 1, then that means I'm going to leave that exponent positive. Now for the second part, I have 42,605,000. Again, no decimal place, so I assume that my decimal is right here. I'm going to have to move that decimal place in between the 4 and the 2. So I end up with 4.2605 times 10. I move it 1, 2, 3, 4, 5, 6, 7 places. And because 42,605,000 is a number that is larger than 1, I again leave my exponent as a positive 7. For this next example, my decimal place is right here, and I need to move that decimal place all the way over here so that it's in between the 2 and the 6. So I have 2.67 times 10, and I moved it 1, 2, 3, 4, 5 places. But because my number originally started out as a number that was in between 0 and 1, I know that my exponent then has to be negative. And then my last example, my decimal place is here, but I need to move it all the way down here in between that 1 and the 1. So this gives me 1.1 times 10, and I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. Okay, and because my original number here is a number that is in between 0 and 1, my exponent must be negative. Now for example 3, we're going to go in the opposite order. I'm going to be given a number in scientific notation, and we have to write it in standard notation. Well, standard notation just means kind of like normal, okay, like what we would normally see. So when I see that for part A, it says that the temperature of the sun's core is 1.55 times 10 to the 6 Kelvin, this exponent here of 6, oops, let me change my color, tells me that this is a number that's going to be greater than 1. So I'm going to have to move my decimal place on this 1.55 to make it a number that is greater than 1. So if I start out at 1.55, I'm moving my decimal place 6 places, and I'm going to have to move it to the right in order to keep my number greater than 1. So I'm going to move it 6 places, so there's 1, 2. Now for every place now, because I've run out of numbers, I'm going to have to fill in zeros. So I've gone 2, so here's 3, 4, 5, 6. So I'm just going to come over here and write in my zeros. So again, you can just double check. I've got 1, 2, 3, 4, 5, 6 decimal places. And if I go and I pop in my commas where they belong, that's 1, 2, 3, 1, 2, 3. So this is going to give me 1,550,000 Kelvin. So this is that same number that was written in scientific notation, now written in standard form. Now for part B, it says the lowest temp that was recorded in the lab setting was 2 times 10 to the negative 11th Kelvin. Because I have this negative exponent, that tells me that I'm going to be moving my decimal place, which is, I have 2, and my decimal place is really right here. I'm going to have to move that 11 places, and to make that number fall in between 0 and 1. So that means I'm going to have to move my decimal place then to the left. So I'm going to move it 11 places. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And you can go ahead and fill all those in with zeros. And if you want to clean it up some, ultimately what that turns into is a decimal point. 10 zeros, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then the number 2. And this right here would be your final answer. When you are comparing numbers and writing them in order from least to greatest or largest to smallest, okay, the first thing you want to do is you want to compare the numbers in scientific notation, or to compare the numbers in scientific notation, you first need to compare their power of 10. Okay, and you can order those accordingly. Remember, if you have negative exponents, the larger the negative, the smaller the number is. And then if I end up with, like, let's say 2 numbers that have the same exponent, that's when we need to go and start looking at the decimals themselves. So if we look at this down below, we have the mass of a neutron, an electron, and a proton. So right away what I notice is I notice that the electron has a negative 28 exponent. So I know that that's going to be my smallest. So I'm going to write the electron. And then I also notice that my neutron and my proton have the exact same exponent of a negative 24. So now what I have to do is I have to come and I have to look at my decimals and tell me which one is bigger and which one is smaller. So I am going from least to greatest, so I want the smallest decimal written first. So I have 1.67, so that's both of these go up through 6, 7, but then I have 2, 6, and 4, 9. Well, the 2, 6 is going to be the smaller one of the two, so that tells me that the proton comes next, and that the neutron then is going to be slightly larger than the proton. So these would be my my proton, neutron, electron in order of increasing mass. And again, you can see it all typed out here. So for example 4, we have a similar type situation. So these are all positive exponents. So for the smallest one, I'm looking to have the smallest exponent, which in this case would be the Uranus. So this is my smallest. Then my next largest is going to be either Saturn or Neptune, but both of them have an exponent of 26. So I'm going to look at my decimals. So I have 1 and 5.7. Well, 1 is smaller than 5.7, so that tells me that Neptune comes next, followed by Saturn. And then that leaves me then with Jupiter as the last one. And that has the largest exponent as well to confirm that. And again, here are those same answers typed out. Now we can also perform mathematical operations with scientific notation. So when we are multiplying, essentially like in part A here, what I really have is I'm taking my 7 and I'm going to multiply that by 4, and that's still going to be times 10 to the 5th. So what I end up with then is I end up with 28 times 10 to the 5th, which is fine. However, 28 is not a number that is in between 1 and 10. So what I have to do is I have to readjust it. So to readjust it, what I'm going to do is I'm going to move my decimal place from the end of 28 and push it up in between that 2 and the 8, which will give me 2.8 times 10. And because I moved that 1 decimal place, I'm going to have to add 1 to the top. So that will become 2.8 times 10 to the 6th. And this would be my final answer for part A. Likewise, for part B, I'm going to multiply that 0.5 times 1.2, and I'm still going to maintain my times 10 to the negative 3rd. So when I simplify that, I end up with 0.6 times 10 to the negative 3rd, which is great. However, I can't have this 0.6 because that's not a number in between 1 and 10. So that tells me I'm going to have to move my decimal place over here. So I end up with 6. And because I'm moving my decimal place, I do have to, in this case, I'm really subtracting 1 because I need to make this number bigger, not smaller. So this is going to make that 6 times 10 to the negative 4th. Now, if you don't know, if you can't think about this logically in your head, I could always write 0.6 as times 10 to the negative 3rd out. And I have 0.6, my decimal place, because it's a negative third is going to be moving in this direction, so I'm going to have to move that decimal place. There's 1, 2, 3, so I end up with 0.6 or 0.0006. And then if I were to redo this, I could say, well, I really had to move it 1, 2, 3, 4. So this is really 6 times 10 to the negative 4th. So you could also work it out too if it doesn't make sense logically as to how to come up with that. Okay, for example 6, we're just going to multiply, and I have 9.5 times 10 to the negative 4th times 2 times 10 to the negative 5th. So here I'm going to multiply the two whole numbers. So this gives me 9.5 times 2. And then I'm going to multiply that by 10 to the negative 4th times 10 to the negative 5th. So when you simplify, this gives us 19 times 10. When I have the same base, remember I add my exponents. So 10 to the negative 4th times 10 to the negative 5th actually gives me times 10 to the negative 9th. And then the only other thing I have to do is I have to clean up the fact that 19 is not a number in between 1 and 10, so I'm going to have to move my decimal place in between that 1 and the 9, so I end up with 1.9 times 10 to the negative 8th. And that is my final answer. For the second part, I'm going to multiply. I have 5 times 4, and then this is going to be times 10 to the 7th times 10 cubed. So 5 times 4 is going to give me 20 times 10 to the, keep the base, add the exponents, so this gives me 10 to the 10th. And again, I can't have 20, I need a number in between 1 and 10, so I'm going to make that 2.0. That means I have to add 1 to that exponent, so I end up with 2.0 times 10 to the 11th. For this next one, I have 6.1 times 8 times 10 to the 9th times 10 to the 14th. And this is going to give me 48.8 times 10 to the 9 plus 14 is 23. So this is really going to give me, I have to move my decimal place one place over. So I have 44.88 times 10 to the 24th. And then our last example, I'm going to multiply the 9 times 0.3, and then make that times 10 to the 12th times 10 to the negative 18th. So 9 times 0.3 is going to give me 2.7. Then I have times 10 to the 12 plus a negative 18 is going to give me to the negative 6, and this can just stay as it is. Now our last example is a power to a power, remember? And if you recall, we have to distribute this outside power onto everything that is inside. So really I end up with 7 to the 3rd times 10 to the, and when I have a power to a power like this, remember I multiply, so that becomes times 10 to the 15th. And 7 to the 3rd power is 343 times 10 to the 15th. I need to rewrite 343 as a number in between 1 and 10. So that becomes 3.43, and I did move my decimal place 2 places, therefore I have to add 2. So this is going to give me 3.43 times 10 to the 17th. Likewise, for the next one, I'm going to have to distribute that negative exponent onto everything. So I have 5 to the negative 3rd times 10, and I have a power to a power, so this becomes times 10 to the negative 6th. 5 to the negative 3rd is really 0.008, and I'm going to multiply that. It's 1 over 125, but I have 0.008 times 10 to the negative 6, and I need to move my decimal places 3 places over. So I have a number between 1 and 10, which is 8. And because I moved my decimal place 3 places over, I'm going to have to subtract 3 here, which is going to give me to the -9th. So this right here is going to be my final answer for that one. And then the very last one, I have 1 times 10 to the -5th being raised to the -5th. So this really gives me 1 to the -5th times 10 to the -5 times -5 is going to give me a positive 25. So 1 raised to any power is still going to give me 1, and then I just have times 10 to the 25th, and that there will be my final answer. Please let me know if you have any questions. Otherwise, I hope you have a great day, and I will see you in class.